Improvement of traffic safety and operation is our common goal. However, traffic accidents still occur. Leaders from academia, industry, and government are working together to accelerate the deployment of advanced ITS communication technologies to tackle this global challenge. ITS communications have two major categories: direct communication for vehicles and infrastructure systems, called V2X, and V2N, where signals are communicated through telecommunication networks. Direct V2X communication is suitable for collision avoidance and automated driving purposes, and network-based V2N is good for broadcasting information to broad areas and large amount of data. DSRC, Dedicated Short-Range Communication, is a V2X technology specifically developed for transportation safety applications. An appropriate mix of these two different technologies, V2X and V2N, is a good approach for ITS communication. This mix is sometimes called hybrid communication and already is applied to vehicle and infrastructure systems around the world. DSRC technology for safety is developed based on well-established stable Wi-Fi technologies. There are recent proposals to use ever-changing cellular technologies for direct V2X communication. There may be some confusion about DSRC and cellular V2X. Let us explain the facts. In the United States, Europe, and Japan, DSRC is designated as the technology for direct V2X communication because DSRC technology was developed specifically to satisfy transportation safety purposes by experts around the world. With these collaborative efforts, DSRC technologies were validated and already applied to real-world deployments in those regions. Approximately 6,200 units have already been installed in the U.S. by U.S. DOT and state DOT as of 2019. Numbers of roadside units and infrastructure are progressing steadily in each region of the United States, Europe, and Japan. DSRC is a well-established and proven technology, and this stability is a key factor for vehicles and transportation systems due to its long history and its promise of future success. A misinterpretation of this stability is that it is an obsolete technology. But again, this stability is an important factor for transportation systems. DSRC is also designed to evolve into its next-generation technology, properly named NGV, Next Generation Vehicles. Experts are developing this next-generation technology now under IEEE. Since NGV is an evolution of DSRC, it is designed to assure interoperability, coexistence, and backward compatibility with DSRC. DSRC already has a well-established ecosystem, and it will be further enhanced with an evolution with NGV. While there is no interoperability, coexistence, and backward compatibility between LTE V2X and Future's NR V2X, cellular V2X. That is also the reason why only DSRC is reliable at this time. DSRC is already adopted in Japan, Europe, and the United States. In China, the government and industry are moving toward introduction of another technology, often called cellular V2X. A number of pilot projects are underway in China to deploy LTE-based V2X and V2N applications. V2N using a cellular technology has a good possibility for infotainment because it enables transportation authorities to monitor vehicles in a broad area to improve traffic operations. V2N, by definition, requires use of commercial cellular network by carriers. To start with, LTE is a voice and data communication technology. Following on from 3G and 4G, we are now at the stage of welcoming 5G, which features high-capacity, ultra-high speeds, substantial connectivity capability, and low latency. However, it needs dedicated infrastructure that will require enormous cost and time to build out. As such, the places 5G can be connected to are limited. Various advertising questioning whether cellular communication technology can be used for V2X is causing confusion. Thinking related to adopting technology used for phones that are replaced on average every 2 years, while the life cycle of vehicles is approximately 12 to 15 years in the US, Europe, and Japan, differs. Established, reliable, and proven technology is necessary for cars for which safety is paramount. Release 14 contains cellular V2X specifications based on LTE technology. However, since the US standard SAE J3161/1, which stipulates the basic safety message, BSM, regarding safety has not yet been determined, Release 14 cannot be used for cars for which safety is the #1 priority. Release 16 contains cellular V2X specifications that use new technology known as New Radio, NR. The specifications for Release 16 were scheduled to be fixed in March 2020. However, that has been postponed, and the standardization schedule going forward remains unknown. There is also a plan to formulate Release 17. However, at this time, it does not comply with the SAE standard, so it is not known when V2X safety can be secured. There is often confusion between 5G and cellular V2X. They are related but different. 5G has 2 major phases of technologies, LTE-based and a newly developed New Radio technology. Both LTE and New Radio communications have 2 modes, network-based UU and direct PC5. 2 technologies and 2 modes can confuse people. The technology being considered in China is LTE-based and for both direct and network-based communication. This PC5 mode is similar to DSRC communication. However, safety with PC5, even Release 14 basis, has not been established yet. For safe driving, what are the technical requirements being sought for V2X communications? One of the difficulties with V2X is that you don't know which car will be the service partner. For that reason, it's necessary to adopt technology that will allow each car to transmit its location and speed at regular intervals, and also allow nearby cars to reliably receive that information. DSRC utilizes a CSMA with CA technology. At random timing, it first confirms that no other car is transmitting before sending out data. Only one car occupies the channel, thus all the surrounding vehicles are able to receive the information that is sent. As each car periodically carries out these random transmissions, stable communications are achieved. DSRC is a mature technology that satisfies the V2X requirements. On the other hand, with cellular V2X, the frequency has been divided into units of 1 millisecond subchannels, and this is the resource the cars use to communicate. Each car checks the usage status of the resource for the most recent 1 second, and then randomly selects one of the resources that is in the bottom 20% of power consumption to communicate. The resource selected by each car is used every 100 milliseconds continually for between 0.5 seconds and 15 seconds. Using the resource in this continuous manner is known as semi-persistent scheduling, SPS. Cellular V2X differs to DSRC in that it allows simultaneous communication among multiple cars by using subchannels and repeatedly using the same resource. Due to these differences, there is the possibility of several issues occurring. The first issue is the persistent packet collision problem. If multiple cars select one resource, communications using that resource will continually collide. The second issue is the persistent half-duplex problem. When multiple cars transmit simultaneously, even if different subchannels are used, they will not be able to hear each other while transmitting. The more subchannels that are set, the more likely it is that this issue will occur. The third issue is the persistent near-far problem. In the situation noted above, according to the positional relationship of the receiving vehicle, the strength of the signal from a nearby car will be too strong, meaning there is a possibility it will not be able to hear the transmission from a car that is farther away. In response to these issues, there is technology that can use different resources to retransmit the same data. However, this will consume double the resources. So when traffic is congested, there is the risk that this will further exacerbate the issue. For cellular V2X to mature as a V2X communication technology, it will need to prove that communication in difficult circumstances can be established. ITS communication will enhance safety and efficiency of our transportation systems. Government agencies have already allocated dedicated spectrums for these V2X communications around the world, and DSRC V2X technologies in Japan, Europe, and the United States have been expanding for our ultimate safety goals.